Local mode is not only the default mode in which you will get your access points most of the time unless you ask for a very specific setup from Cisco, but otherwise it will be in local mode. And also, it's probably the mode in which you will have your access points, most of them, most of the time. So in local mode, what happens is that your access point is primarily set to service clients. So it will be on a channel in 2.4 and in 5 GHz, and it will be sending and receiving traffic to and from clients, just like you would expect from an access point. The reason why we mention it and we spend some time on it is because in that mode, the access point not only is going to service a channel, but you also want that access point to be able to understand what is happening on the other channels, because the AP wants to detect the RF environment so that you know about its sources of interference, but also because the AP wants to know about the other 802.11 devices that may belong to your network, that's your neighboring access points, and that's useful for RF grouping, but also the access points that do not belong to your network. That could be your neighbors, or that could be people trying to attack you. Any unwanted access point is called a rogue. We want to detect those rogues. So how does that work? Well, the AP is going to be primarily on a channel, for example, channel 1 in 2.4. And it's going to spend, I would say, 99% of its time on that channel. And at regular interval, the access point is going to jump for just a few tens of milliseconds, 50 milliseconds as you see here, to another channel, channel 2 for example, and then it will come back to its main channel, spend a long time there. And then after a while, it's going to jump to the next channel, 3, and then come back, and then jump, and come back, etc. So you see, it's going to stay primarily on channel 1 in BG, but it's going to also every now and then jump to the other channels one at a time in sequence to be able to discover the environment. It does not stay very long on the other channels, but enough maybe to hear interferences, or maybe enough to hear the beacon from another access point or traffic from another access point. And that's enough for the AP to report rogues, neighbors, etc. to the controller. Maybe that time on channel 4, for example, will not be long enough for the AP to discover the rogue at that time. But after a few cycles of scanning channel 4, it will eventually come by a time where it will be there at the right time to hear the rogue. So the normal mode, the local mode, is efficient and most of the time good enough for rogue and interference detection in a network where there is no high security and where speed in detection is not critical. So this is on 2.4, and of course the same logic works on 5 GHz. The round-trip time for this scanning is configurable, but by default it's 180 seconds, which means that the AP gives itself 180 seconds to scan all these other channels in 2.4. So that will determine how long the AP stays on its main channel, and of course how long it takes to jump and come back. On 5 GHz the time is a little bit different, and that's because you probably have more channels. The default scanning cycle is still the same by default, and here again you can configure it differently. But because we have more channels to scan, the AP is probably going to stay a little bit less on its primary channel to have more time and more chances to scan the others. So that's the local mode. That's where your AP will spend most of its time, and that's how you would configure it most of the time. But there are some cases where you say, I want the AP to be faster in detecting interferences or detect rogue access points. And there may be some locations where it's more critical than some others. So what you can do in that case is set the AP to what we call a monitor mode. In that mode, the AP is not going to be able to serve any client anymore, right? There is no Wi-Fi traffic there anymore. But what the AP monitor mode is going to do is scan all the time. It's going to spend about 1 second per channel, and it's going to spend its time scanning channel after channel, 36, 40, 44, and counting. So that is very efficient because, of course, you would not configure all your APs in that mode because, again, they don't service clients anymore. But because they're scanning, that allows you to detect whatever may be surrounding you a lot faster. So typically you would find people using access points in monitor mode, for example, at the edge of the network, where they will use that system to detect traffic of your own clients, and that will help in triangulating the location of your clients. Remember the location case in the site survey section? So those APs at the edge would be typically in monitor mode. The second advantage of having those at the edge in monitor mode is that you can detect traffic from the outside and better detect the rogues. You may also have here and there sprinkled inside the network a couple of access points in monitor mode to detect better, faster the interferences. Many networks do not have any monitor mode API at all. because they just think that it's enough to have the local mode access points. Monitor modes are where you want to have good location and when you want to have a faster detection of rows or interferences.